For this example, we're given two functions that we'll graph on the same xy coordinate system, and then we'll name the domain and the range of each function. So first, we have f of x is equal to x squared, and this is our base parabola function. So we know when we substitute -2 in for x, we get 4 for our f of x. When we substitute in -1 quantity squared gives us 1. When we substitute in 0, 0 squared gives us 0. When x equals 1, 1 squared gives us 1. And when x equals 2, 2 squared gives us 4. So let's go ahead and plot those points. We have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. This is our parabola. We'll connect it, make a smooth curve. And this is the graph of f of x equals x squared. Now we have another graph, and this other graph is g of x is equal to the negative of the quantity x minus 1 squared plus 4. So we have some transformations, and in this case, let's start with the negative out in front of that quantity x minus 1. This negative indicates that we have a reflection about the x-axis. So we'll reflect about the x-axis. The x minus 1 inside the parentheses indicates a horizontal shift. Since it's x minus 1, that indicates a shift to the right. So we'll shift 1 unit to the right. And finally, our last transformation will be our vertical shift. We have plus 4 as our vertical shift, so that tells us to shift 4 units up. And I'm going to take each of these 5 original points and do a transformation on each one of them. So let's start with the point -2, 4. First, the negative sign out in front tells me to reflect about the x-axis. So instead of -2, 4, I'll come down here to -2, -4, right about here. Now I have 1 unit to the right. So I move this point to the right 1 unit. And the final point will be up 4 units. So from this red point, I'll go up 4 units, and there's my new point. Now let's do that with the point -1, 1. First, I'm going to reflect that about the x-axis, -1, -1. Then I'll go 1 unit to the right. I'll be right on the y-axis now. And then finally, 4 units up. So from this point 0, -1, I go up 4 units, and I'm right there on the y-axis. My next point is 0, 0. Let's see what happens when I apply the transformation. Well, if I reflected about the x-axis, since it's on the x-axis, I don't need to move at all. Now 1 unit right, I just move 1 unit along the x-axis. And finally, 4 units up, I go 1, 2, 3, 4. I'm right here at this point 1, 4. Okay, let's do the last 2 points. We have the point 1, 1. Let's first reflect that about the x-axis right here. Let's move it 1 unit right there, and 4 units up. 1, 2, 3, 4, right here. And finally, the last point. We have this point 2, 4. Let's reflect it about the x-axis down here at 2, -4. 1 unit to the right, and then 3 units up. Sorry, 4 units up I meant. And we end up right here back on the x-axis. So now we have these 5 points. We can sketch our parabola represented by g of x. So in purple, I have g of x and in the black I have the original f of x. Now let's talk about the domain and the range of each of these functions. So the domain, first of all, for f of x. Since f of x equals x squared is a parabola, the domain of all polynomial functions is all real numbers, so from negative to positive infinity. In other words, I can let x equal any real number. Now how about the range? Well, if we look at the picture of our graph, we can see that the lowest y value we have is 0, and then all the other y values are greater than 0. So the range of that function is from 0 to positive infinity. And then finally, let's look at the domain and the range of g of x. So for g of x, let's first talk about the domain. G of x is again just a parabola. It happens to be a parabola that opens downward, but it's a polynomial function, and so the domain of any polynomial function is always from negative to positive infinity. How about the range? Well, the range is any y value that appears on this graph. If you take a horizontal line and bring it up along the y-axis, you can see that the largest y value occurs right here at the point 1, 4. So the range, the y values are no greater than 4. They can be 4, but no greater than 4. So one way we can write this is that y is less than or equal to 4, but since I typically write this in interval notation, I'll write it as negative infinity up to and including 4.